All right, this video is on solving rational equations. And just like when we were adding and subtracting, we're going to to find the least common multiple of the denominators. And sometimes when we're finding the least common multiples of the denominators, they just call it the least common denominator. But we found least common multiple before, so this concept isn't new. On the first one, the least common multiple of 3 and 2 would be 6. So once we find that least common multiple, we're going to multiply each term by 6. And when we do this, it looks complicated, but it's not that big of a deal. I'm going to take this 6 and divide it by 3, which is 2, and then multiply it in the 2 in the numerator. And 2 times 2 is 4, so we get 4x. Okay, 6 times 8 is 48. All right, let's try that fraction trick again. 6 divided by 2 is 3 times 5 gives us 15x. 6 divided by 3 is 2 times 7 is 14. And now that the fractions are cleared, this is just a regular equation that we can solve. So we're going to subtract 4x from both sides. So I get 48 equals 11x minus 14. Add 14 to both sides. So I get 62 equals 11x. Divide by 11, and fractions are totally fine as long as they are reduced. And we're done. But since we cleared the fractions, then we didn't have to work with them at all, and it made it easier. All right, let's look at number 2. On number 2, the least common multiple of 4 and 2 is 4. Now, if you misthought this and said 8, 8's actually going to work out just fine. You're just going to have more reducing at the end. But if you work with the least common or the smallest common multiple, it tends to work out a little better. So now I'm going to multiply everything by 4. 3 times 4 is 12x minus, now try our trick again. 4 divided by 4 is 1 times 3 is 3. Over here, 4 divided by 2 is 2 times 9 is 18x. All right, now to solve for x, we're going to subtract 12x from both sides. And that gives us 18 minus 12 is 6x. Divide by 6. And x is negative 1/2. All right, let's try number 3. Now, number 3 and the rest of them are different because they have variables in the denominator, but the process is identical. So my denominator is x plus 5. So it's the only one I have. So that has to be the least common multiple. So I'm going to multiply everything times x plus 5. And when I do that, on the first fraction, the x plus 5's cancel, and I just get negative 4. On the second fraction, nothing cancels, so I have to distribute this, and I get 6x plus 30. Over here, the x plus 5's cancel, and I get negative 7x. It's just a regular linear equation, so I got to combine like terms. So I have 26 plus 6x equals negative 7x. Subtract and get all the variables together. So I have 26 equals negative 13x. Divide by negative 13. So x is negative 2. All right, let's see what happens on number 4. Try this again. Number 4, my least common multiple. Well, I only have one denominator, so it's got to be x plus 7. So I'm going to multiply each term by x plus 7. When I do that, here they cancel, and I just get negative 7. Over here, nothing cancels, so I have to distribute. I get 6x plus 42. Over here, it cancels, and I just get x. So I want to solve. I'm going to combine like terms, and I get 35 plus 6x equals x. Subtract the 6x, so I get 35 equals negative 5x. Divide by negative 5, so x is negative 7. All right, and we need to go back and look at something that I didn't point out from the beginning intentionally. When we solved 1 and 2, in the denominators, all we had was numbers. And when you have numbers and you clear the fractions, whatever answer you get is what you get. The problem comes when you have variables in the denominator. Okay, When you solve these problems, there's a chance that you can get what's called an extraneous solution. And an extraneous solution is an answer that looks like it's correct, but it actually doesn't work. Well, how would that be the case? Well, because we have fractions, you can't divide by 0. So if your answer makes one of the denominators 0, it's extraneous. Now let's look at number 3. On number 3, if I put in a -2 there, -2 plus 5 is 3. That's not 0. Same thing over here. So I'm not going to have to divide by 0. I don't have a problem. This answer is good. But now let's look at the next one. On number 4, I get x is -7. If I plug in -7 here, I get -7 plus +7, which is 0. You can't divide by a 0. So that means that even though we did all the work and it came out nicely, this is actually a false solution. It doesn't actually work because it can't give you an answer due to the fact that it makes the bottom 0. So this one is considered extraneous. So you will write it on the answer blank of your quiz or test, but you will mark that it's extraneous, indicating that it doesn't actually work when you plug it in. Okay, I want you to pause the video and do number 5 on your own. See if you can work it out. It's just like the ones we've been doing. Okay. Hopefully you were able to get that x was 5. Your least common multiple was x plus 6. Multiply everything by x plus 6, and then you can solve your equation. All right, number 6, same process. We're just going to get a different type of answer, or something different is going to happen, I guess I should say. The only denominator is x plus 2, so that has to be my least common multiple or my least common denominator. So I'm going to multiply everything by x plus 2. Now, just like when I was adding and subtracting, if you've got a minus, change it to plus and negative. Some of them won't make a difference, but man, some of it really will. On that first term, nothing's going to cancel, so I have to distribute. 2x times x is 2x squared. 2x times 2 is 4x. On the second fraction, the x cancels, so I just get this -3. So I can write plus a -3 or -3. It doesn't matter. Over here, nothing cancels. X times x is x squared. X times 2 is 2x. Now, what makes 6 different than the other ones we've had, the other ones were all linear. But if you notice, 6 has an x squared, which makes it quadratic. And to solve a quadratic, you first have to set it equal to 0. Second, you're going to factor. And third, you're going to write equations and solve. Okay, so let's look at number 6. When we set it equal to 0, we have to keep the x squared positive. In order to keep the x squared positive, I need to put everything on the left side. So I'm going to subtract x squared, make sure I'm lining up like terms, and subtract 2x. So this gives me x squared plus 2x minus 3 equals 0. Okay, we set it equal to 0. Next step is to factor. There's no greatest common factor. It's a trinomial with a leading coefficient of 1. So I'm going to go straight to my 2 parentheses. The two numbers that multiply to -3 and add to 2 would be 3 and -1. When I solve, x equals -3 and +1. But now I need to check. Will any of these answers make my denominator 0? If I plug in -3, -3 plus 2 is not 0. If I plug in 1, 1 plus 2 is not 0. Neither answer is extraneous. They both work. I would say about 30 to 40% of the time, you're going to get an extraneous answer. So it's really important that you keep checking. All right, number 7, we got to find the least common multiple. But to find the least common multiple, those denominators have got to be factored, just like when we are adding and subtracting. So this is not new. This is the same thing we had to do. So to factor this, I can take out an x, and I have x plus 1. My least common multiple, I'm not repeating anything. I'm just making sure everything is represented. So I have an x, and I have an x plus 1. Okay, so that is my least common multiple. So I'm going to multiply everything times x plus 1. Okay. On the first fraction, the x's cancel out and so does the x plus 1. So all that leaves me with is -6. On the next one, nothing cancels out. So what I need to do, I'm going to write this out big, and then I'm going to take 1 times x plus 1. Well, I can multiply them in any order. 1 times x is just x. So I have x times x plus 1. So I'm distributing that. Okay. So when I distribute, I get x squared plus x equals, on the other side, this time just the x plus 1 will cancel, and I get -6x times x, which is -6x squared. This is quadratic, and it's quadratic because it has an x squared in it. So first step, set it equal to 0 and keep my x squared positive. So I'm going to add 6x squared to both sides. And when I write my answer, I want it in descending order. So I want x squared, x, and then a number. So I have 6x squared plus x minus 6 equals 0. All right. Now I need to, I totally lost my train of thought. I apologize. Oh, wait a second. I see what I did wrong. X squared plus 6x is not 6. X squared plus 6x is 7x. Okay, so now we set it equal to 0. So now we need to factor. So when we factor, there's no greatest common factor. It's a trinomial. The leading coefficient is not 1. So we're going to split the middle term. So 7 times -6 is -42. The two numbers that multiply -42 and add to 1 would be 7 and -6. So I'm going to rewrite it, splitting the middle term. All right, now I'm going to factor by grouping. Out of the first two terms, I can take out a 7x, and that leaves me with x plus 1. The sign comes straight down. Out of the next two terms, I can take out a 6, but I'm really taking out a -6, so that changes the sign. So I have positive x and then plus 1. So now when I rewrite it, I have x plus 1 and 7x minus 6 equals 0. So when I write my equations and solve, one equation is x plus 1 equals 0. So I solve and get x is -1. Here, if you kind of cover up that x minus 1 for a second, you're trying to solve 7x minus 6 equals 0. So that means that you need to add 6 to both sides and then divide by 7. So x equals 6/7. But now we need to check. If I plug -1 in, think if I plug it in right here, -1 plus +1 is 0. We are not allowed to divide by 0. So -1, even though it looks like a good solution, it doesn't work, which makes it extraneous. If you plug in 6/7 and 1, I don't know what that is, but it's definitely not 0. Same thing if you square it. I mean, it's not going to work. Okay. So this are my two answers, but I marked this one extraneous. So again, if you were taking a quiz or a test, you'd put both answers there. You just mark the one extraneous. All right. Number 8, nothing needs to be factored, but you have more than one thing. And the least common multiple needs to have everything represented. You're not going to do multiples of something. You're just going to represent everything. So my least common multiple will be x times x plus 1. So now I'm going to multiply everything times x plus 1. Oops. Except I just miswrote that. All right. On the first fraction, got a couple things going on. On the first fraction, the x plus 1's cancel. So I just have x times x, which is x squared. On the second fraction, be careful because this minus is plus a negative. The x will cancel, but what I need to do now is distribute the -4. So -4 times x is -4x, and -4 times 1 is -4. Equals on the other side, this time the x plus 1 cancels, so I have -2x times x, which is -2x squared. So because I have an x squared, it's quadratic, I need to set it equal to 0, and I want my x squared to be positive. So I'm going to add 2x squared to both sides. So x squared and 2x squared is 3x squared, and then minus 4x minus 4 equals 0. So I set it equal to 0. The next step is to factor. There's no greatest common factor. It's a trinomial. The leading coefficient is not 1, so I'm going to split the middle term. 3 times negative 4 is negative 12. Now I need two numbers that multiply to negative 12 and add to this negative 4, which would be negative 6 and 2. So I'm going to rewrite it as 3x squared minus 6x plus 2x minus 4 equals 0. Out of the first two terms, I can take out of 3x, and I have x minus 2. Plus, out of the next two terms, I can take out of 2, and I've got x minus 2. I rewrite it as x minus 2 times 3x plus 2. And now when I solve, the first one is going to give me x equals 2. On this one, if I set this equal to 0 and solve, I've got to subtract 2, so I get negative 2, and then divide by 3, so x equals negative 2/3. Now, you don't technically have to do this in your head, but if you can do that, your life is going to be much easier because that skill is something you're going to have to do quite a bit. All right, now let's check. If I plug in 2, 2 plus 1 is 3, or for 2, that's not going to be an issue. Even negative 2/3 won't cause an issue. So both answers are good, and neither one is extraneous.